Hey everybody, I just wanted to do a couple of short videos today. One of them addressing this concept of degrees of freedom, and then later on I will do one involving the idea of why do we use the t-distribution when we are running inference procedures on means rather than the normal distribution, right? So if you did the reading, you've noticed we're not using the normal distribution for these hypothesis tests or confidence intervals involving means. Why not? So there'll be a video out later on today discussing why we use t-distribution and not normal. But for now, I want to discuss the idea of degrees of freedom. So the t-distribution comes along with it some complications, one of them being this idea of degrees of freedom. Basically, all degrees of freedom means is how many independent or free pieces of quantitative information go into a parameter estimate. All right, sounds like some fancy wording, but parameter estimate, remember, that's just a fancy way of saying a statistic, right? So every time we obtain a statistic, the idea is we're using that to estimate some overall population parameter. Okay, now in the case of sample means, and again, we will be using the t-distribution when we discuss sample means. Remember, a sample mean is calculated by taking, let's say, our n people or n items and measuring some quantity from them. So we're going to sum up those n quantities, and then we're going to divide by n. All right. Now, how many free pieces of information go into that estimate of x bar? Well, let's say that we knew ahead of time that x bar was equal to 25 in a sample of 4 numbers. And just below that, you see 4 lines. These represent my 4 numbers, and I haven't filled them in yet, so I'm going to fill them in now. The first number, it could be anything I want. Let's say -20. You didn't see that coming, right? You thought, oh, it was going to be a positive number, but no, that's a completely free choice. Obviously, if the context is something where the values have to be positive, then yeah, okay. This would definitely be a positive number, but in general, this is a completely free choice of mine. That second number, also completely free. 0. Interesting, Mr. G. Yes, I know. 0 is a crazy choice. Moving on. This third choice, remember, I'm still aiming for an average of 25. However, this third choice, whatever I want it to be. Let's go with 20. Obviously, I'm making things easy on myself. So I have 3 numbers out of 4, and those 3 numbers sum to 0. I want the average of the 4 numbers to be 25. This last choice must be 25. Okay, I have no freedom in that choice once I have my first 3. Okay, and that's why we say that when we have the statistic of sample mean, there are n-1 degrees of freedom, because in this case I had 3 free choices in my estimate of x bar, if n, and in this case n was equal to 4. So my degrees of freedom were 4 minus 1, which of course equals 3. All right, so that's why for the t-distribution, when this idea of degrees of freedom comes up, we will calculate it by taking the sample size minus 1, because there are n-1 free choices in that calculation of x bar. All right, I don't want to just leave it there. I'm going to show you another example with chi-squared tests. So just FYI, the fact that we're all doing this home learning thing, chi-square tests have been cut out of the AP exam. So you won't need to know this for the AP exam. However, this is still an important hypothesis procedure in statistics, and some of you may have seen this in your own research. So I wanted to touch upon it And if we do finally meet again in class after the AP exam, we will be talking about the chi-squared test. Chi-squared test also has its own calculation of degrees of freedom. So the way chi-squared test works is we have two categorical variables, let's say food and age of a person. And you might want to say, does age depend on food preference? Or vice versa, does food preference depend on age? It really doesn't matter the way you state it, but that might be a typical type of question on a chi-squared test. And then the way we measure that, the way we answer that question is we obtain counts. So we go to, let's say, in this case, it turns out 70 people of various ages, and we ask them, what do you prefer, chicken, beef, vegetables? All right, very simple. But really what we're looking at here is, now we have our sample information, okay? How many free choices go into this table when we are, if we know that let's say the total number of chicken was 15, the total number of people that said beef was 25, veggies 30, and also the total number of 10-year-olds was 10, total number of 10 to 20 was 20, total number of greater than 20-year-olds was 40. So how many free choices do we have when filling out this table? Well, let's start. This very top left blank cell, it could be anything I want. Obviously, there are limits to the freedom and due to the context, but this can be anything between, 0 and 10. Let's just say it's 2. Okay. Yes, this was a completely free choice. Moving on to the beef under 10. Let's say it's 5. Okay, moving further to the right. I know that under 10-year-olds said chicken, under 10-year-olds said beef. Well, this last choice, not free. Okay, I know that if the total number of 10-year-olds was 10, then this last choice has to be 3. See, I can do math. All right. Let's go to the next row. 10 to 20. So there are a total of 20 10 to 20-year-olds. Let's say 15 said chicken, 5 said beef. Well, this last choice, again, not free. 0 in this case would have to say veggies. So 10 to 20-year-olds, got to pick up your game. Veggies are good for you. Don't ignore veggies. Okay, and now let's go to this last row. Oh, actually, I see I messed up. Going back, the total column for chicken was supposed to only be 15. So let's say this was 13 and this was 17. My bad. 7. Okay, 13 and 7. My bad. All right. Anyway, going down to this last row, in the chicken column, I'm stuck, right? This is not a free choice. Okay, this has to be 0 because a total of 15 people said chicken. Further down, so far, 13 people have chosen beef as their favorite. Sorry, that's 12. I told you I could do math. 12 people have chosen beef as their favorite. However, there are a total of 25 that said it. Again, this choice, not free. 13 greater than 20-year-olds had to have said that they prefer beef. And now this very last cell, once again, I'm locked in. So 27 over 20-year-olds said that they prefer veggies. See, once you hit the age of 20, you become a little bit more health conscious and you start eating your veggies. You'll see that'll happen to you too. All right. Anyway, the point is, how many free choices did we have in this case? Well, it turns out only 4 out of the total of 9. Okay, well, how do you calculate degrees of freedom in general? I'd like you to think about it for a moment, but I'm gonna just scroll down and tell you. But please pause and think if you want to challenge yourself. But as it turns out, that in general, for a chi-squared test, when we are looking at sample counts or sample frequencies, the degrees of freedom will equal number of rows minus 1. So in this case, we had 3 rows. So the degrees of freedom will be 3 minus 1 times the number of columns minus 1. And the number of columns in this case was 3. But I would take that and do 3 minus 1 and take those numbers and multiply them. And so in this case, 3 minus 1 times 3 minus 1, that'll give us our degrees of freedom, and that equals 4. And as you can see, there are only 4 numbers that do not have stars next to them. Remember, those starred numbers represented numbers that were not free choices. So there are 4 degrees of freedom. And that's a strange looking 4. I'm gonna rewrite it. All right, there we go. Now things are as they should be, because that looks like a real legit 4. All right, and that's, I think, all I had to say. So I just want to do a quick video with this idea of degrees of freedom sort of alone, because there were a lot of questions about it yesterday, and that's okay. There always are questions about degrees of freedom, but basically all it means is how many free choices do you have in a statistic, and in a quantitative statistic. All right, ladies and gentlemen, that will be all for this video. Keep a lookout for the next video, which will be, why do we use the t-test? All right, take care, everyone. Bye.